Hi everybody, if you're having any trouble on 8.1i, hopefully this tutorial will help you out. Let's go through the introduction. A model rocket blasts off and its engine shuts down when it is 25 meters above the ground. Its velocity at that time is 50 meters per second. Assume that it travels straight up and that the only force acting on it is the downward pull of gravity. In the metric system, the acceleration due to gravity is 9.8 meters per second squared. The quadratic function h of t equals 1/2 times negative 9.8 times t squared plus 50 times t plus 25 describes the rocket's projectile motion. All right, on number 1, we're going to define the following variables found in the equation. T stands for time, but in this particular problem, the time is a little bit complicated. This function is only relevant for after the engines have shut down. It's the t is the time since the engines shut down. And it's measured in seconds. H stands for height, measured in meters. Number 2, what is the real world meaning of h of 0 equals 25? In other words, explain what is going on when t equals 0 and h equals 25. So in function notation, what this means is that we need to plug the number 0 into the function named h. And when we do that, we'll get 25. So here's the function named h. And when we plug 0 in for t in both locations, if we work the math out, we end up getting 25. Now in the function, we're plugging in numbers for t, the time, since the engine shut down. So in this case, the time is 0 seconds and the height is 25. So what h of 0 equals 25 means is that when the engine shuts down, the rocket is 25 meters high. All right, 3a. In the paragraph above, you learned about the acceleration due to gravity. How is gravity, or g, represented in the equation? So we learned that the acceleration due to gravity is 9.8 meters per second squared, and we notice it's part of the coefficient of t squared. And 3b, how does the equation show that gravity is a downward force? And we notice the 9.8 has a negative sign attached to it. All right, number 4, we're going to do some graphing. We're going to graph the function. And I suggested that you go to the website desmos.com to help, so we'll take a look at that. We'll need to change our viewing window so we can see both sides of the parabola. And we can use Desmos to locate points by clicking anywhere on the graph. Now notice there's some directions here. It says use coordinates to label the Y-intercept, the vertex, and the X-intercept. So once we're done with our graph, we need to make sure we label those 3 points. When we go to Desmos, we need to start graphing. And over here, we will type in our function. Notice down in the bottom left-hand corner of Desmos, there is a little keyboard icon. We can click on that and get some extra keys to hit. Those will come in handy. In Desmos, we can easily make fractions by using the slash key. So to make 1/2, I'm going to type 1, and then the slash key below the question mark, and then the 2, and it automatically makes it a fraction. Now notice my cursor is still in the denominator, so I'm going to arrow over to get out of the denominator, and then I'll start typing again. You can use the exponent key. All right. We see our graph, or at least parts of it. This might not be showing all of the important parts in this graph. So we're going to zoom out and just see if we find anything else that we should include in our graph. Because right now it just looks like a line. I'm going to zoom out. Oh, so we're seeing the other half of something here. We'll zoom out some more. And now we can see that we have a parabola. Now let's reformat this window, the viewing window, so that we can see the parabola better. I'm going to click on the wrench, And for the x-axis, I don't want it to start at negative 320. Let's see, the important part of the parabola looks like it goes from 0 to 10.6 or so. So I want to start well before that. So maybe I'll start at negative 3. And then I'll go to, I want to go a little bit past that. So why don't I go to 12 and see how that works out. And I want to go by ones. It's showing all these little lines that I don't want to see, so I'm going to uncheck the minor grid lines, and that gets rid of all those extra lines. So I changed the viewing window for the y-axis to go from negative 100 to positive 180 and have it go by tens. That worked out pretty nicely. And now we have our graph. We can find some important points on this graph if we just click on the graph somewhere. And we notice that a few points appear. Well, we are interested in the Y-intercept. That's at 0.25. We are interested in the vertex, and we'll talk about what that means in just a moment. And we are interested in the X-intercept. Notice we are ignoring this X-intercept because that happens at negative 0.478 seconds. And we're not interested in what happened before the engine shuts down. So we're going to ignore that X-intercept and focus on this one. Now, to get some more points for our graph, we can continue to use Desmos. If I want to know how high the rocket is after 2 seconds, I can click right there and it shows me, oh, it's 105.4 feet high, or meters high. After 2 seconds, after 4 seconds, I could click on the graph and hold, and it says, oh, after 4 seconds, it's 146.6 meters high. Maybe after 6 meters, and after 8 meters, or after 8 seconds, excuse me, it's 111.4 feet high. After 10 seconds, 35 meters high. So we can use those points to make a nice graph over on our worksheet. So here's my version of the graph. Notice I have labels for both axes. It says the vertical axis tells us how many meters high the rocket is. Horizontal axis tells us how many seconds since the engine shut down. And then I use those points we were talking about over in Desmos to make my graph. And when we connected those points, we have a nice parabola. Right, at number 5, how high does the rocket fly before falling back to Earth? And when does it reach this point? Well, the highest point that the rocket flies is up here at 152.6 meters. And that happens 5.1 seconds after the engine shut down. And at number 6, how much time passes while the rocket is in flight after the engine shuts down? So we can look on our graph to see when the rocket hits the ground. And that happens when the height is 0, when it's 0 meters high. So the graph is at 0 meters high over here, which happens 10.7 seconds after the engine shuts down. There is one point from number 4 I just noticed that I have not labeled, and that is the Y-intercept. So I'll go ahead and do that right now. And number 7, we're wondering when is the rocket 60 meters above the ground? And it points out that we're going to have 2 answers. And that's because the rocket will be 60 meters above the ground on its way up and 60 meters above the ground on the way down. I'm going to move this horizontal line up to 60 meters to help us locate where on the graph is 60 meters, as close as possible. And we're going to move the vertical line over to the point on the graph on the way, when the rocket is on its way up. If we follow that vertical line down, we see that the rocket is 60 meters above the ground, a little bit less than 1 second after the engine shuts down. Now I'm going to slide that vertical line over, and I notice that on the way down, the rocket is 60 meters above the ground, a little bit less than 10 seconds, so maybe 9.9 seconds. All right, hopefully this tutorial answered any questions you have about 8.1i. Signing off.